This is the FAA Part 107 Remote Pilot Study Guide for 2025. Today's video, we're going to be discussing latitude and longitude on sectional charts. Part 107 questions are included in this video, and we'll be discussing everything in perfect detail. So let's jump right in. Part 5 of 12 starts now. Have you been looking at a sectional chart and you feel as if you're trying to decipher some ancient map? It feels almost impossible to figure out, doesn't it? Well, in this video, we're going to be breaking it all down, latitude and longitude. And what's so good about this video is that you're actually going to be getting hands-on trying to find specific locations based on coordinates that I will be providing. The questions that you'll see on this video will be the same questions that you will have on the Part 107 exam. So let's start with a basic question. What is latitude and longitude? Well, instead of me just telling you what everyone else has been telling you, let me break it down to you this way. You see, back in the old days of early exploration, sailors had a big problem of trying to figure out exactly where they were in the vast open ocean. They had no GPS, no satellite, no smartphones. The only thing they had were the stars in the sky to guide them, the sun, and their maps. And in the frustration of trying to find out where exactly they were, they realized that they needed to have a grid system to divide the Earth into precise locations. Imagine trying to take a long trip and you have no roads, no road signs, and no jurisdictional boundaries. Don't you think that it would be difficult for you to go from point A to point B? Well, this is the reason why latitude and longitude and sectional charts exist today. I bet you've never heard anyone explain it to you quite that way. Now let's talk about latitude, which was the easiest thing to figure out first when sailors first noticed the North Star. You see, the North Star always maintained its position in the sky, but its height was changing depending on how far north or south these sailors were traveling. And they used their measurements and their references to mark an invisible line running around the middle of the Earth. And that latitudinal line is called the equator. It was the first line of latitude and it was marked at 0 degrees. And these sailors started marking other horizontal latitudinal lines that were running parallel from the equator as a reference. And these other parallel lines were running north and south of the equator. These are all lines of latitude that were created. Now let's talk about longitude. You see, these same sailors that were sailing from east to west following the lines of the equator didn't have any idea of exactly how far they were going. They knew how far they were going if they were going from north to south, because from the equator at 0 degrees, all they had to do was to travel for 60 minutes north or south, and that will bring them to the next line of latitude, but they didn't have a reference point from going east to west. So what do you think they decided to do? They decided to make lines that were running from north to south instead of the ones that were running from east to west, such as the equator. They decided to make lines that were running from north to south, and these lines are called longitudinal lines. And with these lines marked off at certain distances, or should I say this correctly according to the Part 107 exam, lines of latitude and longitude are marked off by minutes. So let me just take some time here and explain this to you very carefully. If the equator is at 0 degrees, then the next degree north of the equator, for example, will be at 1 degree. Now, similarly, the next line of latitude that is south of the equator at 0 degrees will be also at 1 degree. So you have 0 degrees for the equator, 1 degree north, 1 degree south. Those are 3 separate lines of latitude. Now, here's the thing you need to know. If I am at the equator and I'm going from 0 degrees to the next line of latitude north at 1 degree, then how many minutes are in between? The answer to that question is 60 minutes. And the reason I'm stressing minutes is because on the Part 107 exam, they will ask you to find the location based on a coordinate that is 30 minutes south and 60 minutes east. They will ask you those questions and you have to know how to find it. So write this down on a piece of paper now, or commit this to memory, whichever one suits you. The distance between each degree for latitude or longitude equals 60 minutes. And on a sectional chart, you will need to know how to count these minutes so you can find the precise location. And some of you who have already been looking at the sectional charts, you may be a little bit confused because at 1 degree you will see that there's a line, and then another degree you will see that there's a line, but there's another line in between that separates the two, and that is at 30 minutes. I'm going to explain all of this to you in a few minutes. Now, I've just given you a very visual but basic idea of what latitude and longitude actually means. And you know something? I just realized that I needed to tell you something else. Let me ask you this question. If the line of latitude at 0 degrees is called the equator, then what is the line of longitude at 0 degrees called? I'll bet that most of you do not even know that answer. And that's why I'm here to tell you. The line of longitude at 0 degrees is called the prime meridian. And this line of longitude running from north to south goes directly through Greenwich, England. And you know, if I was listening to this, I would ask a question. Why Greenwich, England? And you know, it may not pertain to the Part 107 exam directly, but it is a good question. You see, just like the sailors who marked the equator at 0 degrees, well, a 0 degrees of longitudinal line had to be established also. And it was established in Greenwich, England, because that's where most of the world's shipping charts were established as a point of reference. The location of the prime meridian is at the Royal Observatory in Greenwich, England, which was established in 1675 by King Charles II. The primary purpose of this Royal Observatory was for improving navigation and timekeeping for sailors. And it's very interesting to me when you put 2 and 2 together and figure out that 60 minutes between latitudinal and longitudinal degrees are also equivalent to 60 nautical miles. Okay, so enough of that. Let's get into the sectional charts and apply everything that we've learned so far about latitude and longitude. And the first thing that I'm going to spend some time with you on is how do we find coordinates on sectional charts? Finding coordinates. Now you see I'm pointing to 35 degrees on a line of latitude. You know that this is a line of latitude because not only is it horizontal, but it's running from east to west. And as long as I stay on this line, no matter how far I go around the earth on this line, I will always be at 35 degrees latitude. Now if I move over to the left, you will see that I have another coordinate here, currently at 35 degrees latitude, but there is another intersecting line, and that is 100 degrees longitude. So you see I'm at 35 degrees latitude at 100 degrees longitude. This is where I'm at right now. And if you look over to the left, you will see that that is 101. 1 degree away from 100 is 101. So what did I tell you earlier in the video? In between every degree of latitude or longitudinal lines is 60 minutes. And if I were to count these little minute lines, or should I say more appropriately, tick marks, then I will find that there are 60 little tick marks in between 101 degrees and 100 degrees. And if you were observant, you notice that there were some slightly larger tick marks. Those indicate 5 minutes, and then some really big tick marks, and those indicate the 10-minute increments. And you'll find these for both latitude and longitudinal lines. Now, do you notice from what I mentioned earlier that in between 101 degrees and 100 degrees that there is a line separating them? That is not a longitudinal degree. That is a 30-minute mark, often called a half a degree or 0.5 degree mark. And you're probably wondering, why are these here? Well, the reason they're here is because the more increments that you have on a map, the more precise your plotting and navigation will be. Let me move to another coordinate so that way we can talk about longitudinal lines. Now, there's something first that I want you to notice. That way you're not too confused when you're taking the exam. From 113 degrees longitude to 114 degrees longitude, do you notice that they're closer together? I can see 113 and 114 degrees, but if I'm looking at latitude lines and I'm trying to find out where the next degree is, you will also see that it takes some time to find the next degree laterally, either north or south. It seems as though there is less distance between the lines of longitude than there are the lines of latitude. Let me show you. In between 114 degrees and 113 degrees, there are 60 tick marks or 60 minutes. Now I'm scrolling like you would not believe to get to the next line of latitude, and here is 37 degrees, and going directly above, it took a long time to get to 38 degrees. Now, can you explain that? When you're working with the sectional charts, you will find that it seems difficult to go from 1 degree of latitude to another degree of latitude because they're so far apart. Just keep in mind that even though your brain is understanding that there is a greater distance, that there is no difference. There are still 60 minutes in between latitudinal and longitudinal degrees. And for those of you who are still curious and want to know why, like me, let me explain. Lines of latitude always remain the same distance apart, no matter how far north or south they are from the equator. They're parallel and they never intersect with each other. But lines of longitude run north and south, and they do intersect with each other at the north and south pole. So logically and mathematically, the distance in degrees for longitudinal lines will vary differently according to where they are on the Earth. So if you're at the North Pole and all of the longitudinal lines are intersecting at that point, you could literally be standing and walk 360 degrees of longitude just by turning in a circle. Now, isn't that crazy when you just think about that? Well, there is something that's not so crazy, and that's hitting that like or subscribe button. Now let's go ahead and see if we can give you something that's fun to do. We're going to discuss about understanding coordinate formats. I'm going to give you some coordinates either in degrees, minutes, and seconds, or some coordinates in degrees and decimal minutes, or coordinates in decimal degrees. I will explain all three of those formats shortly, but what I want you to do is to take the easiest one first, and based on the coordinates that I'm giving you, tell me what is at that specific location. Now, some of you who are using either a computer or a laptop, you'll be able to go to skyvector.com where you can pull up these sectional charts, and that will make it easier for you to navigate to find the coordinates I'm about to give you. And for others who have mobile devices such as tablets or smartphones, well, I'm going to keep the charts on the screen so that way it will make it easier for you to find the location that I'm referring to. Now, this is not a test. I'm not trying to scare you. This is just an exercise. I'm trying to get you into looking for locations based on coordinates that are given to you. This is what's going to be on the Part 107 exam, and you need to know how to do this. So here we go. First, understand that coordinates can be written in different formats. The first format will be degrees, minutes, and seconds. The second format will be degrees and decimal minutes. And the third format will be decimal degrees. For the Part 107 exam, they will be throwing around different formats, but that won't be a problem for you because you'll understand exactly what they're referring to. So let's break it down and use these coordinates as an example. And you see below that the coordinates are also in decimal format as well. So let's start with the first number, 38, which has a little symbol to the top right, and that represents degrees. And from what you have just learned, you already know instinctively that we're talking about either a latitude or longitude line. So how do we determine which one it is? And that's easy peasy, because all you have to do is to look to the right and you will see the north symbol or letter N. And what that is telling you that it is 38 degrees north of the equator. So if there is something 38 degrees north of the equator, which we already discussed is at 0 degrees, then it's reasonable to assume that this is a degree of latitude. And just to eliminate any confusion in your brain, latitude always comes first in these coordinates, and I'll tell you why. It's because latitude measures how far north or south you are from the equator on a horizontal position. Remember the story I told you about the sailors on which one they marked first? It was the equator at 0 degrees based on the position of the North Star. So latitude came first before longitude, and this order has been followed traditionally on an X and Y format used in mapping and navigation. I'm giving you this detailed information because it doesn't make it easier for you to remember what I'm saying, it just makes you remember. Let's move to the next number, 52, and this number directly after the degrees equals minutes. Now let me go into detail by probing your brain. How many minutes are there in 1 degree? If you can't answer that question, then rewind this video and start all over again from the beginning. There are 60 minutes in between each degree of either latitude or longitude. And by saying that, you can see that we're looking at only 52 minutes. It's not exactly 60 minutes yet, but it's close depending on your point of view. It hasn't quite made it to a full degree yet. If it said 59 minutes, then it would need only one more tick to get to another degree, which instead would say 39 degrees at 0 minutes. So we're talking about 38 degrees heading north of the equator, and we're continuing north by counting 52 minutes north of 38 degrees. Now the number after 52, which is the number 6, indicates seconds. Now keep in mind, there are no tick marks in regard to seconds. You just have to sort of approximate or guess where 6 seconds are within 1 minute. Now moving to the next degree, which is 77. Can you tell me whether or not this is latitude or longitude? Well, I already know that all of you got this correctly because you understand that first it's latitude and then the next one will be longitude. Now, I don't need to stress into detail here. You already know the principles, but what I need to point out to you so you remember, this is 77 degrees west of the prime meridian, which the prime meridian is at 0 degrees. So you're going west of the prime meridian at 77 degrees to get to this coordinate. And just so you know, I don't think I mentioned this earlier, but all longitudinal lines are also called meridians. Now look at the coordinates again so I can make some additional clarifications. The letter W is telling you that you're running west. You're looking west, 77 degrees west of the prime meridian, and also the minutes and the seconds are also moving west. So everything here is on a westerly direction. What this means is as soon as you find 77 degrees west of the prime meridian, start counting west, 0 minutes and 42 seconds. Now guess what? This is something you're going to be happy about. I just gave you enough information so you'd be able to take any set of coordinates and find the location by yourself. And you're going to ace the Part 107 exam, but not until you know about the other formats, which I'm going to discuss shortly. And before I do that, I want to give you some advice. When you're looking at the sectional charts and you're trying to determine these coordinates, the easiest way to do this is to simply take the 38 degrees latitude, for example, and the 77 degrees longitude, for example, and put yourself in the general vicinity. You don't need to count the minutes or the seconds yet. Look, if you were looking for a certain location, you wouldn't be staring at your toes while you're walking and taking little steps, would you? You would look for the closest landmark and you would get there as fast as possible. And then once you're there, you would look around, take little steps to orient yourself so you can get to the precise location. Now, I know this is a lot to take in, so pause the video when you need to, take a break, and we'll get back into it. And while you're doing that, I'm going to put these coordinates up on screen and leave them throughout the remainder of the video. You'll see them flashing. What you can do, if you'd like to practice, is to find what is at this location based on the coordinates I just gave you and post it in the comments. And just so you know, these coordinates are in your testing supplement, so you'll just have to find out which chart has these coordinates. And no, it is not the coordinates to my house. And that being said, let's look at some other formats for latitude and longitude coordinates. Now, if you notice, the coordinates that I gave you originally, I also gave it to you in decimal format. This is something that you might see on the Part 107 exam. I did. And the key thing to remember here is that decimal format is simply just an approximation. It is not an exact pinpoint location. It's there for you to quickly determine where a specific location is, but approximately where it is, not exactly where it is. So when you see these decimal formats like the one I'm displaying up top, think that you only just want to get an approximate location. So 38 with the decimal after, and you already know that latitude comes first in any format, right? And then after the decimal, you see the number 8,683. Now logic and mathematics alone will tell you that you're getting very, very close to making that into a 39 point. Right? So that means that whatever it is that you're trying to calculate in regard to the minutes or the distance, it is very close to 39 degrees. So when you're looking at the sectional chart, you're looking for 38 degrees, but you're also looking for something along that line that is close to 39 degrees. Now, on the other hand, we're looking at 77 with a decimal there. You know that this is longitudinal. So 77 degrees west of the prime meridian. And then we have, after the decimal point, we have 0117. Now, you know that there's not really too much there. So really, this number, if you round it off, is looking more like 77 degrees, right? And it's not a big number here that's making us feel like we have to push it over to 78 degrees. It's just a small number. So there aren't that many minutes and seconds here, so it's relatively close. The decimal format is just a quick reference to give you approximately where something is located. And this doesn't seem seem too difficult, right? Especially the way I'm explaining it to you. And even this formula that's showing you how to convert degrees, minutes, and seconds over to decimal format is very simple. And if there's a question on how to convert one format to another, well, I'm showing it to you on screen right now. Do you see 38 degrees, 52 minutes, and 6 seconds? Well, I can convert that into a decimal format simply by using this formula. And you can see if I take 38 plus 52 divided by 60 seconds plus 6 minutes divided by 3,600. Now, how did I get 3,600? You're probably asking that, right? Quick and easy. 6 is a factor of seconds. That means that there are 60 seconds in 1 minute. And for minutes, there are 60 minutes in between one degree to another. So if you take 60 seconds and multiply it by 60 minutes, the answer that you will get is 3,600. And when you have all of the values and you add them together, the result will be 38.8683 degrees north. Now, as complex as that seems, do you see how easy that is? And the same principle applies to the longitudinal value also. Now, here's where I'm going to ask you some easy Part 107 questions for you to find locations based on specific coordinates I'm throwing up on your screen. You can also use the testing supplement because these questions are going to be based on the figures that are in the supplement, and it will also give you a good idea of what you're going to be experiencing while you're taking the Part 107 exam and having to use your testing supplement to find specific coordinates that are on your sectional charts. Now, take this advice. When you're taking your exam and you have a question that has to do with latitude or longitude or coordinates, do not look at the answers first. Go ahead and solve the problem, find the location that they're looking for, and then go back and choose the correct answer. Now, I have the downloadable PDF version of the testing supplement on my screen. I just want to show you some examples so you'll know exactly where to go. Once you turn the page to page 2 of 19, you will see figure 20. And figure 20 is where they're asking you to go to find the information. And I'm zooming in so that way you can see the little red balls that are on the screen. That little red ball is telling you figure 20 area 1. Now, I just zoomed up to go to the little red ball that says figure 20 area 3. And within that location is where you want to be focusing your attention. So let's put the question up on screen. Refer to figure 20 area 3. Determine the approximate latitude and longitude for Currituck County Airport. Now, you'll see there are 3 answers there. Don't look at the answers. Don't stare at them. Just go to your sectional chart and determine exactly where that airport is located based on the information that you already know. I don't need to keep the question on screen anymore. Tell me where that airport is located and what the coordinates are. You can do this. You already have the knowledge in your head. You just need to apply it. This is the same location on another sectional chart that I just pulled up. What I'm looking for first is the location. Currituck Airport is my focus. So I need to find some lines of latitude and longitude that intersect or are near that airport. Remember, we're sailors. We don't know where we are. And what I see first is a line of longitude running north and south that is at 76 degrees. That is my first clue. And what's so cool is that the airport is almost directly on that line of longitude. So I don't really need to count too many minutes. And somewhere on a scratch pad, I'm going to write down the coordinates for the longitude. Remember, latitude comes first. So you see how I put my longitude? I have confirmation. Now I'm going after the latitude coordinate, which is going to go in front of that. And the latitude line I see north of Currituck Airport is at 37 degrees. And Currituck Airport is south of that degree, so I already have my latitude number at 36 degrees. Now I just need to find the minutes. And that's very easy because they're giving you the minutes in tick marks. And remember what I taught you, the half degree mark or the 0.5 degree mark is right above Currituck Airport. And every half degree is 30 minutes. So all you have to do is go to the 30-minute mark and count down and you will find your minute answer. So here we are just above Currituck Airport, 36 degrees at the 30-minute mark, counting down 29, 28, 27, 26, 25, 24. Got it. And you can see my answer on screen, which matches the answer on the FAA Part 107 exam. And the correct answer is 36 degrees, 24 minutes north, 76 degrees, 1 minute west. And you can expect that question on the Part 107 exam, but you already know how to find the answer. Okay, so let's do another one. This time I won't show off, okay? I'm going to take it slow so you understand exactly what you need to do for the exam for yourself. I'm not going to hold your hand on this one. You're on your own. So here's the question on screen right now. Refer to figure 23. What is the significance of the symbol located at north 32 degrees 22 minutes and west 81 degrees 18 minutes? Now, I recommend that you use your testing supplement so it can simulate you actually taking the exam, but if you don't have it, then just follow along on screen. I'll do my best to keep everything in place. Now remember, I won't be showing you how to get the answer, but I will be giving you information to guide you to the right direction. Now, do you see how the FAA gave you a slightly different format? You don't see the seconds on this one, do you? Now listen, whenever it is that you're at the starting point of a journey or a search, you need to establish a reference point first, and the reference point is the degrees. Look for the degrees that are the most clear on your chart, and I already know you're looking at them on your right. You just don't know where to go yet. So I'll give you 2 hints. Do you need to go north or do you need to go south towards the equator? Another hint, do you remember the 30-minute marker in between degrees? See, I'm saying these words to you because they all have purpose. They're allowing your brain to connect the dots. Now I'm scrolling up so that way you can see the 30-minute mark for latitude. Not giving you the answer here, just guiding you. And your brain is going to try to force your eyes to look at the answers, but don't do that. Only look at the answers after you've solved the problem and you just need confirmation of your answer. So I've given you enough time. Write your answer down. Let's go over this. The first thing I'm looking for will be latitude or longitude degrees, and I see them immediately top right, and I'm going to use these coordinates to get me roughly in the area of where I need to be. North 32 degrees means I need to go south, because if I went north I would be at 34 degrees. So I'm going to go south, and the first line that I see is my 30-minute marker, and that's a good thing because it's telling me I'm south of 33 degrees at the 30-minute marker. That means that I'm at 32 degrees 30 minutes, and you see I'm close because I'm trying to get to 22 minutes. And all I need to do from the 30-minute marker is to count down to 22 minutes. Remember I did that when I was showing off? But to save time, I'm showing you where 22 minutes is right now. And what you should be doing is scanning along that line going west to see exactly what's there. But don't make any decisions yet. Let's find the second coordinate, which is 81 degrees 18 minutes. And I've zoomed in a little so you can see the tick marks for minutes clearly. Now you already know that this line represents 81 degrees longitude. So we've already confirmed the first part of this equation. And now we only need to go to 18 minutes. And the tricky thing here is, where are we counting from? Pay attention. The coordinates say we need to go west. So we're counting 18 minutes west. And as I point to my markers, I look down and there's a VFR checkpoint. And to my right over, there's a VFR checkpoint. So the answer to this question is a VFR checkpoint is indicated, and mark B as your correct answer. And guess what? You should be extremely proud of your accomplishment because you did that one all by yourself. Take a break, let your thoughts collect, and we'll do this again. So probably the most difficult question on the Part 107 exam that has to do with coordinates is going to be this one that I'm about to give you right now. And you know what's so crazy? What I mean is that it used to be difficult. Now it's the easiest question on the Part 107 exam, and this is an actual question that came from the Part 107 exam, and you're looking at it because it's up on screen right now. Go to your testing supplement and refer to figure 21. What airport is located approximately 47 degrees 40 minutes north latitude and 101 degrees 26 minutes west longitude? And you know what's so beautiful is that I know as I'm speaking that this terminology does not sound unfamiliar to you. So here's where I cut you loose. I'm kicking you out of the nest. You are now on your own. Find that airport. And the good thing about this is that in figure 21, there are only 3 airports. So the process of elimination alone is going to assist you with finding the answer. But you'll be able to find the answer even without any additional assistance because you're ready and you're already there. Your mind has all the information that it needs to solve this problem. But if you have any questions or concerns, you can always leave a comment and you know I will answer. Part 6 of 12 will be uploaded next week, so it's recommended that you hit that notification, subscribe, so that way you can get the updates on when the video will be released. I hope you all got some valuable information from this video. I will have more. Stay tuned. We'll see you on the next one.